Hello, in this video we'll be looking at creating a web API to send push notifications to Xamarin apps using Azure notification hubs. First of all, we need to set up with Firebase and Apple so that we can enable cloud messaging for Android and we can enable the Apple push notification service and configure that setting to ensure that we can use notifications. So first of all, I'd advise you to have this documentation up by your side as we go through this video, because I will be referring to it throughout and I can't keep it on the screen so that you can see what I'm doing. So the first thing we need to do is create a new project in Firebase. We'll call this project Push Demo App, and we'll continue. I'm not going to be using any of these Google Analytics, and it will create our project. Obviously Firebase is for Android. We can use it for iOS, but it's not the preferred option for many. Okay, our new project is ready. Continue. This will take us to our project. We need to configure for Android, so do click this button. Our Android package name is your name or company name or some sort of identifier, and then the package name. In this case I'll call it Push Demo App. We can have an app nickname. I'll call that Push Demo App, like that. We can register the app. It will produce a Google services.json file, and we need this, so please download it and make sure it is safe. Next, well, actually we'll be doing it through Xamarin, nothing else, so we need to just continue to console, and we're all good. And now if you go to settings, project settings, cloud messaging here on the top, you'll find a server key. Now this server key is private, and obviously I will be creating a new server key once this is done. This is important, so please save it somewhere. I'll save it, I can just leave it here for now. And so once we've done that, if you look at the documentation that I mentioned, that's Android pretty much done from the Firebase side. Now we go to Apple. We'll need to create a new certificate, but for that we actually need a new identifier first. A new identifier, be it app ID, continue. Continue. The description will be Push Demo App, and the bundle ID will be, I'll use the same one we did there, so Push Demo App, just like that. We need to scroll down here and make sure push notifications are enabled. Continue and register. Now our identifier is ready. We can enter, and if we go to push notifications, we can configure the certificates. For now we only need a development certificate. Creating a production certificate has exactly the same process. So I'll go ahead and create a certificate, and I need a certificate signing request. To get a certificate signing request, you need to go to keychain access, and here at the top, certificate assistance, request a certificate from a certificate authority. Put in my email address, and I can save this certificate signing request to my desktop, and that has been created. Now I can close that and upload the file from desktop and continue. And now I've got a certificate created. I can download it, and that will be, I can double click on it and then go to keychain access, and you should be able to identify this one by the bundle identifier, Apple development, so you can select both and export to and I'll call this certificates, but I will mention this is a distribution, a push distribution certificate, just so that I know what it is. You can put a password on your certificate. I won't. I'll just put in my keychain access password. That is to log in rather than to do anything else. And that's about it. Now if we go back and go back here, I can create I've got a certificate here for my push demo app, Apns development iOS. So now I'll just create a development certificate to use, and I can just use the same certificate sign-in request, I think. Continue and download. Obviously I do have a development certificate already. If you haven't, then I'd advise you to do that. Now we're pretty much done from there as well. So now you can go to Microsoft Azure, and if you haven't got an account, do make an account. You do need to put your card details in, but if you're careful and you know what you're doing, you shouldn't be spending any money really. So we'll create a notification hub here. Notification hub, let's come up and click create. You can choose your subscription. I'll create a new resource group. A resource group can be used so that you can delete multiple resources at the same time and manage them at the same time when, for example, you've decided you want to delete an app or something. I'll call this push demo app. Click OK. The notification hub namespace, well, you'll make this namespace and it can be pretty much anything. I'll call it push demo app. Okay, seems that's available. The notification hub itself will be we'll give that a name, so I'll call it push demo app notification hub. Choose a location. I would suggest choosing a location that is close to most of your users. In this case, UK South for me. Select your pricing tier. Obviously there are different tiers. Right now I think 1 million pushes is enough, and 500 devices is also enough. If you do want to upgrade, you can at any time. As you can see, the prices are slightly expensive for standard, okay for basic. You can add any tags. I don't think we need any tags right now. Review and create, click create. Resource has been deployed. You can go to the resource, and this will, as you can see in the settings, there's Apple, Google, Windows, Windows Phone, and a load of others. And we need to configure our notification hub with those services so that we can use them. So for example, we've got Apple. We'll need you can either do a certificate or token. I've done certificate. I think it's just easier. And you can configure that, and Google will need an API key as well. Now I just want to show you what happens right now. If we do a test send and select Apple, and we send that, we will actually get a failure. And same thing goes for Android, and same thing goes for all of them actually. We will get a failure. And I just want to show you that so that once we have configured it, you can see that it does work. So first I'll do Apple, I think. And if you scroll down in the docs, you should be able to get to configure your notification hub with APNS information. So if we select certificate here, and certificates push distribution. Now, for now, we are, sorry, I should have said development actually. This is not distribution. In fact, I will rename it now. So I'll upload the certificate and into the password, but we didn't actually set a password, so we're fine for that. Production or sandbox. Now, Sandbox is basically development. We are not doing production so far. Right now, Sandbox. If you do not select Sandbox, you will have problems. We can save these now, and that should be fine. And we can also do Google while we're at it. And for Google, it's quite simple. We just copy this server key and paste it as our API key. Just click Save, and that is now updated. Now, if I go to test send, and first let's do Apple, and I send this, notice that this should eventually work. Okay, successfully sent test message. That is great news. That means we have configured it correctly. Same thing for Android. If I send that, I get a successfully sent test message. And that is absolutely brilliant. Now the next step is to, so now we've configured our notification hub with FCM, so Firebase Cloud Messaging, and APNS, Apple Push Notification Services. Now we can create an ASP.NET Core Web API backend application. And before we do that, I just want to show you how this notification is going to be sent. I just want to show you a diagram outlining how exactly we're going to work. So here we are, we've got our different components here. And I just want to illustrate what's actually going to happen. Well, our app, our Xamarin.forms app, is going to be running here. So I'll just write XF so we know we're talking about Xamarin.forms. And then so let's talk about Apple first. Apple, when the application starts and when a user wants to register for notifications, whether that be done automatically after they've logged in, or we can do it every time they open the application and they haven't registered, for example. Apple device communicates with the Web API backend. How do we do this? We do this through a HTTP request. And we'll communicate, and we'll actually make a request to install, to register this device for notifications. And to register, we will need, for example, a device token. And the example in the Microsoft Docs does this very nicely, and I think I'll stick to that. Now, this thing says, okay, well, we've received a message from this Apple device, a request in fact, saying we want to register. So it processes those details and communicates with the notification hub. And the Azure notification hub, or Azure I should say, says alright, it registers the device, and now when we want a notification, well, when we want a notification, we can start the cycle from a different perspective. Let me just use different pen color. So we want to, our Web API backend has decided we need to issue a notification. And either that's because a certain event has been triggered, a certain action has been taken, or in fact we could make a post request from for example Postman, and that might trigger the API to do something. So anyway, our Web API backend decides we need a new notification. So it prepares the notification and sends it to the notification hub. Well, the notification hub does two things. First thing is it sends it to the Apple push notification service, and it also sends it to Firebase Cloud, the Firebase Cloud Messaging Service too, i.e. Firebase, and these will do their own work out of our hands. We can't do anything with them. Apple push notification service will send the notification to the Apple device, and the Firebase Cloud Messaging Service will send it to the Android device. And note that this, from here, we can only send to the registered devices anyway. Now what we can have is tags. So when we register, I'll go back to red. When we register, we can put in a tag, and the tag can be, for example, news. And so this registration will register the device with a news tag. And so when we decide from the API we want to send a notification, well, if it's notification related to news, you would put a tag here and say news. And we're assuming the Android device, for example, isn't registered for news, say it's only registered for sports. And so when this notification is sent, only those with the tag will receive it. So we'll have news here, and we'll have news here. And this notification will go to this Apple device, which is registered for news. But this will not go to the Android device. And I mean, if we have an Android device registered for news, it will go to it, but this one in particular isn't. So I hope that gives you an idea of what is actually going on. Right now, we're going to work on the Web API backend. And the Web API backend will be hosted by Azure, and we'll be able to communicate to the notification hub from our Xamarin.forms application via the ASP.NET Core Web API backend. The first thing we do is create a new project. We should be able to go to .NET Core, Web App, ASP.NET Core, and create an API. Make sure that's selected. Next, we can choose this target framework 3.1. And we'll call this push demo API. Click create. Okay, that should be able to create our application for us. And now do keep the docs obviously open by your side. And let's just wait for it. Okay, it's done. Now we can actually run this. And the reason the docs say run it is because you might get a message saying invalid development certificate. If you do get that, you can run a tool, or you can, I think the other way is to respond to a prompt that does it for you. So if we go to controllers, we see our weather forecast controller. We're told to delete this weather forecast controller. And we can also delete weatherforecast.cs. And we need to set up our configuration values using the secret manager tool. To do that, you can reveal in Finder to go to the actual folder, and we want the folder that contains this CS project file or CS prod file. So here I will create a new terminal, and I'll run the following commands. The first one is .NET user secrets init, and then .NET user secrets set notification hub. I'll make that slightly bigger so it's clear, :name, and this will actually be the name we set for our notification hub. And to get that, I'll actually go, I'll bring that window up. If I bring that window up, you should be able to see the push. So this is our notification hub name. So I'll copy that and paste it as our value. Click enter, press enter rather, and it successfully saved notification hub name as that. And you can see you need to make sure that your spelling is on point, otherwise you will have issues that will be hard to find. So .NET user secrets. This time we need to set the notification hub connection string, and to get the connection string, you need to go to access policies, and since you see there are two connection strings here. One is for listening to notifications. That will be used in our client application, as it says in the warning here. And the second one, the default full shared access signature, is the listen, manage and send. We need that in our backend application. So I will just copy that and go back to the terminal. And when you paste it, make sure it's in quotation marks, otherwise you will have problems. Paste that in there. And obviously do not share this connection string with anyone. Obviously I will be recreating this. Okay, it turns out I missed the set. Never mind. Okay, that should work fine. And the next thing you need to do, and I'd highly recommend doing this, is setting an API key. And so .NET user secrets set authentication API key, and you want to set something that is relatively safe. For the purposes of this video, my API key is literally just going to be my API key, just like that. And I'll make sure I write that down somewhere so that we don't forget it. Okay, now that that is all configured, we can go back to Visual Studio, and we can now go to here and create a new folder. The folder will be called Authentication. Is add a class here, and we will call it, what will we call it? We'll call it API key auth options. And I can copy directly in from here what we have. We are inheriting, and I should include that using directive. Use that using directive. We are inheriting from authentication scheme options. This is fairly self-explanatory. The next thing we do is create API key auth handler. And this handler, as it says in the docs, is a type that implements the behavior of a scheme. In this case, a custom API key scheme. And our custom API key scheme, we can just copy the implementation directly in here and include a few using directives. Link list claims identity. Okay, now this is slightly more complicated. All you really need to know here is that we are finding our API key from our HTTP request, and if there's no API key provided, or the API key is incorrect according to the string.equals method, then we will return that failure. Otherwise, I think everything else is fine. Now the next thing we need to do is create new class API key authentication builder extensions, and this is a simple static class. Static obviously meaning we do not need an instance of the class to be able to use its methods, hence this is a static method. And this is just some slightly irrelevant stuff. that is important. We haven't actually got to the main bit, the main logic yet. Now in startup.cs we need to update configure services, which is this, to include the following. We need to add the following authentication options, and obviously we do need a using directive. What this will do is just add what we've just implemented in the classes, and so that we can use the appropriate methods. What we also need to do is add app.use authentication here, and that should be absolutely fine. And now we get to the interesting parts, the parts that drive the logic behind this web API. So first thing we do is manage Nuget packages. Manage Nuget packages, and we need to include the Microsoft.Azure.Notification Hubs Nuget package. Add that package, accept the licenses, and that has been successfully added. Now the first thing we do is add a new folder, and this folder will be called the models folder. And if we add a new class called push templates, here this class will have our push templates for Android and iOS. Now I'm not sure if you noticed, but if we go back to our into here and go to Apple, this payload matches exactly with this payload. Obviously we have got the backslash to escape the quotation marks, but it is the same thing. The same thing for Android too. We've got our notification and data, we've got our notification, and we've got our data, and inside obviously the same kind of thing. Now the next thing we do is create a new class called device installation. And what this does is it's simply going to be a device installation. An instance will be a device installation, and that will just have information about the installation, such as the installation ID, the platform, the push channel, and importantly the tags. And if you remember what I did explain, the tags will determine which notifications a given device receives. We can save that and continue. We can create a new class called notification request. What this class will do is it will be a notification request, as you can tell, and it will have 4 properties. These 4 properties are text, action, tags, and silent. Now tags by default is set to an empty array. Text will be the text in the notification that will appear to the user. Action will be, well in this case we'll have action A and action B, and it won't be displayed to the user straight away, but we will be able to interpret this action in our Xamarin.forms app to ensure we can take the appropriate action really with response to this notification request. And finally we have the notification. Finally we have the boolean silent. This boolean will determine whether the notification will be silent or not, and whether it will be displayed to the user via the notifications tab, or the pop-up or window, whatever you want to call it, on their device. The next thing we need to do is we create a class called Notification Hub Options. And these options will store just two properties. And those two properties are the name and the connection string. So you've guessed it, the name is the notification hub name, in our case push demo app notification hub. And the connection string is the default full shared access signature that we found on Azure. Now the next thing we need to do, we're done with models. We can close these files, and we can create a new class called, a new folder rather, not a class, called services. And in this folder we'll be storing files that, sure you guessed it, are services. First of all, we need to create an interface. An interface called the iNotification service interface. And these interfaces do make it a lot clearer actually. They do make it a lot clearer for us to understand what is going on. Because certainly these docs do not explain much of what's going on. We create the we add the using directives. Okay, and now this interface, when implemented, the class will have the following three methods. The first one will be to create or update an installation, and it will be asynchronous. The next one will be to delete an installation by its installation ID. And the third one will be to request a notification. Now notice the first two, they will be called when a specific request has been made by the device, by the Xamarin.forms app, and we want to create or delete or update an installation. And these methods will be called by the controller, probably, to do exactly that. Whereas the last method here, the third method, request notification async, this will be called probably in response to a HTTP request from us requesting a notification. Now obviously it doesn't have to be from us at all times. It will be if you have an automated system. For example, if you have a database and the database is updated, and when the database is updated to match to have a certain value in it, for example, you might want to send a notification to your users, and this method will be called. Now the next interface we'll have is the next class we'll have, in fact, will be a notification hub service class. And notice in the docs there is a typo, at least as of February 2021. It should say notification hub service, not hubs service. And this will actually implement our interface, our notification service interface. And if we implement the interface, we will see we have those three methods. I don't want to throw any exceptions here. First of all, we have these three read-only fields, and we'll need to add a few using directives as usual. The first one will be our notification hub client, and this will be a pretty much a handle to our Azure notification hub. The next one will be our installation platform, and you'll see what this will look like once we've done it, and the logger will just be a logger that is received as a parameter. So the first thing we do is in our constructor we need to receive an iOptions of notification hub options and these, you guessed it, will be used to configure the notification hub. And these options will actually contain two things. They'll contain our connection string and our name, both of which we set using the .NET user secret set commands. The second thing we need to take is the iLogger of not type, but Notification Hub service. And we'll call this logger. And so in our constructor, we want to assign to those private fields the logger, of course. The next thing we do is the hub. And this is interesting. We create a notification hub client from a connection string. So we're calling that method which creates a client from the connection string. And the connection string we have, well, as you can see here, we need our connection string and our notification hub path. The notification hub path is the name of the notification hub. So we'll have in our options parameter, we'll have a value property. Inside the value property, we will have a connection string property. And the next thing is the options.value.notificationHubName property. And so that will create our hub. And finally, our installation platform is a new dictionary, and this will hold two values. Let me just copy that in. Two values: notification platform.apns.lower, the name of that, and the actual platform as part of the enumerable from Microsoft Azure notification hubs. Now we need to actually implement this functionality here. So to start with that, first, if we're creating or updating an installation, we need to make sure that our installation ID, our platform, and our push channel have actually been provided. So the first thing we do is if string.isNull or white space device installation dot installation ID, and notice here this operator basically says, well, is device installation null? If it is null, then just ignore this. And obviously, because if we didn't include that and device installation was null, we'd get an error and the program would crash. The next thing to check is null or white space device installation dot push channel. And third thing to check obviously is the platform. In fact, the docs have done it the other way around, but that is no problem. And if any of these are true, then we return false. Notice here we are returning a false, but it is an asynchronous method, and because it's asynchronous, we do need an async here. Now, once we're sure that we have our installation ID, we have our push channel, and we have our platform, we need to create the installation. And we create the installation, and our installation ID will be our device installation dot installation ID. Notice I don't need to use the question mark here, simply because we have made sure it exists. And I shouldn't use a semicolon there. A push channel, that will be our device installation dot push channel, and our tags. Now our tags are the device installation dot tags, and this will be crucial to ensure that we receive the correct devices receive the correct notifications. Now we need to see if we've got a platform. So installation platform dot try get value device installation dot platform, and out var platform. And if we do have that, then we can assign it to our installation dot platform. Now, if we don't have our platform, and it's not in the dictionary we've defined, i.e. installation platform, then we need to return false, because we haven't got a platform. And so therefore once we have got a platform, at this point, if our code is still running on line 49, we have our installation ID, our push channel, and our platform, and our tags, and we have an installation of containing these properties. Now the next thing to do is, and we'll put it in a try, because this may return errors, and if it does return errors, then we've got a problem. So we'll put await, because this will be an async operation, create or update installation async. We need to pass, and notice that this is actually, this comes from the notification hub client class. This is not, these are not the same methods. And we need to pass our installation, which we have, and the next thing we need to pass is a cancellation token. And notice we have that cancellation token here, so we can just pass this cancellation token. Now if we do get an error in this process, then we need to return false. And in fact, I do not need this. I'm not exactly going to worry about debugging the error right now. Now if we've succeeded in all these steps and we haven't had to return false at any point, then our installation has been successful and we return true. Now the next thing we need to implement is the delete installation by ID async method. And the first thing we need to check is that the installation ID actually exists and it's not an empty string or a null. So string.isNull or white space installation ID, because if it is, we return false, and that means our method has been unsuccessful. I do need to make that async. I'll make this async as well. And so now we don't need to do much really. The Azure Notification Hub does most of this for us. We can await hub.delete installation async. We pass the installation ID. That's that. And in fact, we can pass the token as well. If that doesn't go ahead as planned, we return false. If it does, then we return true. And notice this line won't be called if we return false, in case you were wondering about that. Now this is a fairly fun method actually, and in this method we request a notification from the hub. And so the first thing we need to do is make sure that the notification, the HTTP request, has been sent with the correct information. We have got to make sure that we have the required properties in our notification request. And I'll just clear this up from the docs. Okay, so if our notification request is silent and we haven't got an action, then there's a problem. If it's silent and we haven't got text, then there's a problem. Sorry, if it's not silent and we haven't got text, then there's a problem. And if the notification is null or white space, so if we haven't got an action altogether, then there's also a problem. And I think this can be simplified since we have got a repetition here, but do not worry about that for now. Now we need to create the Android push template. And you may think, well, we've got it here in our model, push templates.cs, we have got our Android, but we have got a silent and a generic. So that's the reason why we would go here and say Android push template equals notification request.silent. And so we evaluate this expression here, and if that is true, then we return push templates.generic. If it's silent, .silent.android. Otherwise, so if it's not silent, we return the generic, so generic.android. Same thing goes for iOS. Now we've got the push template, we need to actually create our payload as well. Our payload differs between Android and iOS, so therefore we will need to create this adequately. So our Android payload is, and we'll make a function, we'll make a method here called prepare notification payload. And this method will take our push template, it will take our text, notification request.text, and it will take our notification request.action. And control dot, and we can generate the method. And I'll just change these variables, parameters, sorry. And I'll call this template so that we're not talking about Android. And we can implement that in a second. And this, in fact, returns a string. We do the exact same thing for iOS, except it's an iOS payload. And we need to use the iOS push template. And what I would say here is, instead of passing notification request.text and notification request.action, we might decide to add something else to this in the future. So what I would pass instead is the notification request itself. And obviously I'll change these parameters to get a notification request, and that is of type notification request, notification request. And so if I pass that instead, I think it would be easier for long-term maintainability. And so we can do that later. All it is replacing a few things. Now, once we have got our payload, we can try to send the notification. And if we haven't got any tags, so if notification request.tags.length equals 0, then we will await send platform notification async with Android payload, iOS payload, and the token. As you can see, this method we haven't created yet either. I'll just leave it as it is for the moment. Otherwise, if our notification request.tags.length is less than or equal to 20, then we'll also send it using exactly the same thing, except this time we will be passing our notification request.tags as a parameter as well. And so you can tell now we need 2 overloads for this method. Otherwise, actually with Azure Notification Hubs, send template notification async, which is the method we use, is limited to 20 tags as explained in the docs. So if we have more than 20 tags, then we'll need to send them separately. So we can use the following. So we'll have var notification tasks equals notification request dot tags, and this is where some link comes in. So we'll take that, we'll select, you'll need system.link, the value and the index, lambda expression, value index, dot group by, and obviously this is, you don't need to worry about this, this is just a bit of link, index dot of 20, I dot value, dot select, tags, send, platform, notification, async, with these things here. So that should be fine. Okay. And when that is done, these are our tasks. We will await task.whenAll notification tasks. So this, if you look at it here, this is actually, if this is going to tell us, oh no, we've got an error. This will be a list of tasks. Each one will be a send platform notification async per 20 tags. And we'll just, when these are complete, we'll just await the tasks for when they're complete. And if this all goes to plan, we can return true. Otherwise, if something's gone wrong, exception EX, well, we've got a logger actually, by the name of logger. We can log error EX. And in the docs we say unexpected error sending notifications. Now you don't need to worry about this. This doesn't actually affect the functionality. Well, if we have got an error, we return false. Now, before I implement this, I actually do this. So if we look at push templates, and if we look closely, you've actually got these placeholders, alert message and alert action. So here, what we want to do is we want to replace these. And so this will just return our template dot replace. We'll replace this placeholder alert message with, see, it says text in there, but I've actually passed the notification request. Sorry, by the name of request dot text. And the string comparison dot invariant culture. And then we'll also, before we return it, in fact I'll make this slightly easier to understand. We'll have var payload template dot replace that. We'll also replace, I'll just copy this in, also alert action, we'll replace that with the action in the request, and so then we can return the payload. Now that is complete. Now we need to implement these, and the first one will, if I control dot and generate the method, we should get that, and I'll control dot the second one as well, and I'll generate a method. I'll put this one on top of the other just so that makes a bit more sense. Okay, so the first one will have an array of tasks called send tasks, so a task array like that, and it will be hub dot send FCM native notification async, and that is for Android, so we pass the Android payload and the token, and we'll also have that's a colon there, a comma, sorry, and we'll also send the Apple notifications async. Apple, what did I say? iOS payload, and we'll pass the token as well. And so then we can return task.whenAll 10 tasks. Okay, and now for the second overload, and I'll change this to a task. So as you can see here, we do need to return a value, and our value here is going to be exactly the same. It's going to be exactly the same implementation, except here we will pass the tags as well. And that is absolutely fine. Okay, so now we can rest back, we can sit back, and we can see that all three methods of this interface have been successfully implemented. The next thing to do is configure startup.cs, and that is slightly more confusing. In our configure services method, in here, we need to underneath this services.add singleton iNotification, it's going to be of iNotification service. And if you notice here, we are in this overload. This is our service and this is our implementation, and this is where interfaces come in. That is our implementation, and we can just, that's basically it. Now services.add options, notification hub options, and these options we'll need to configure with configuration.getSection notification hub. This will get our configuration subsection with the specified key. Really, honestly, do not worry about this. This .bind needs to go on the outside. This type of code, this sort of stuff, you do not really need to worry about. It doesn't change between implementation and implementation. Once that is done, we can actually create our controller. We'll right click here and create a new file. This new file in ASP.NET Core will be a web API controller class. We'll call this the notifications controller. Now inside here we've got we can get these out. What this does here, I'll just show you. We've got, so if a GET request is made and there isn't a value, then we call this. If a GET request is called with an ID, so like that, then we take the ID as the parameter and do something to it. If the POST request is made without an ID, we do that. If a PUT request with an ID is made, we do this. And if a delete request with an ID is made, we do this. Now we can actually take these out. We have our own implementations. The first thing you would do is here we need to add an attribute, and that attribute is API controller, and we'll authorize as well because we've chosen to use an API key. Now the next thing we do is in the class we'll have a read-only iNotification service of name notification service, and in the constructor we'll assign this to the iNotification service that we will receive in the constructor, and we've just decided we're going to receive that in the constructor. Now once that is done, in launch settings .json, which is in properties, we need to change the launch URL from weather forecast to API/notifications. Now we need to, I'm just going to copy and paste what we have in the docs, and I'm going to paste it into here. And this is actually very interesting indeed. Okay, let me just clean this up a bit so we can understand what's going on. So these attributes here refer to 3 different requests that can be made. The first one is a PUT request, and the PUT request will produce a response type of either OK, bad request, or unprocessable entity. And at least according to the attributes. And all this will do is the device installation will be received as part of the request, and we'll be calling notification service, which we have here, .create or update installation async. And that notification service is this notification service, the ones we just implemented. And so they will return a boolean, and that boolean will be stored in success. If we're not successful, we return a unprocessable entity result. If we are successful, we want to return a 200 OK result, a 200 OK response. If a delete request is made, then we require the installation ID, and it comes from the root, which we have specified here. Okay. This will call notification.delete installation by ID async, passing the installation ID, and it will say whether we're successful or not, and same thing happens here. And then we have our HTTP post request, which will be made to trigger a notification, to send a notification. And that will take the notification request. So here we check if it's not silent. So if it is silent and we don't have an action, then there's a problem. If it isn't silent and we don't have a text, then we have a problem. And if any of those are the case, we return a bad request result. Otherwise, success stores a true or false, basically, depending on what request notification async returns. And if we're not successful, we return that result. And actually here, we're never going to return a bad request here. And here, we're never going to return a bad request either. So you can forget about those attributes. I think the docs have put them, there by default. Save that. And now we're pretty much ready to go. So now we need to create an API app. And that app is through Azure. So I create a new resource. I search for API app and create. Don't know why it's not responding. Let's see what happens. Okay, our API app, we'll call that push demo app API. And I'll use the same resource group. Okay, that is taken. API 0. Okay, that works. We'll use the same app service plan and location. We'll click create. Okay, deployment in progress. Meanwhile, I will go to my notification hub and I will have my connection string ready. I'll copy that onto my clipboard so that once this is ready, we can set it up correctly. Okay, go to resource. I think it's in configuration. We create a new application string. This will be notification hub name. These are exactly the same things we set in the local version in the .NET with .NET user secrets. And here my notification hub name is, if I recall correctly, push demo app notification hub. And we'll create a new application string, and that is notification hub connection string, and I'll just paste that in. And then we have our authentication API key, and in my case it's my API key. Okay. Now that this is done, I can save, make sure you save. Once that is done, we can go back to Visual Studio. What I did realize is that if you go to startup.cs, you've got to make sure that app.useAuthentication is actually comes before user authorization, because that will result in a 401 unauthorized message being caused. So now what we can do is run this in debug mode in Safari, and if we, so that'll go on, let me just make this all, so if I bring in Safari, I'm now running localhost here. If I open a Postman tab and bring it in, just ignore that, we'll make a new one. And I specify the requests endpoint. I'm going to make a post request as if I'm requesting a notification. And if we have a body here, and for now I'll just leave it as that. Let's see what happens. If I click send, we get a 401 unauthorized. Alright, what I did notice is that actually I did not include my API key. I've been trying it with my API key, but I had the problem before. So if I put in my API key and send that, we get a 200 OK response, which is brilliant to hear. That means it works as intended. Now if I were to change the body, we can just experiment and see what happens. So if I just have an empty placeholder there, we get a 400 bad request 400 bad request response. And if we go to our controller, then you'll actually see here in the HTTP post that we haven't specified everything here, so we get a bad request result. Now if we were to write, if we were to put what was here before, so text action, and if I were to make this silent, make silent true, and let's, what is our thing, so say if it's silent and we don't have an action, so if I were to do that, I'd actually get a bad request. And if we put a breakpoint in here and do that again, see the breakpoint is reached. See that notification request or action is null and silent is true. So we return a bad request result. Now that's not bad. We've got a working API now. The next thing to do would be to control click here. In fact, first you go to release mode, control click publish, and you won't have this here. You probably need to click publish to Azure. It will query your subscriptions. If this doesn't come up straight away, do click refresh and publish. Now we can publish that to Azure, and instead of using localhost, we'll be able to use our actual endpoint, the one that will look like push demo app 0. Here we are, push demo app 0 to Azure websites.net, which I'll just change this request. If we do that and send that, we get a bad request. That's because we've done this. So if I put action and action A, notice we get a 200 OK response. And here, this is all hosted by Azure. This isn't on our, this is, you know, our endpoint. This API isn't running on our local host anymore. It's running on Azure, on the internet. So this means we can access this API from our devices later on. So for now, our API is done, it's published. The next thing to do is to create the Xamarin.forms app. And if you don't want to create a Xamarin.forms app, if you want a Xamarin native app, then I have made a video that goes through that using the same documentation for Xamarin.forms, but with a slight difference so that it works on Xamarin native, that is Xamarin.android and Xamarin.ios. Thank you very much. In the next video, we'll be looking at Xamarin.forms.